All right, everyone. So the point of this video is to understand normal force. So I drew a little box here on a table. It's an awesome drawing, I know. Thank you. And so what I want to do here is I want to talk about like the force of gravity and the force of the normal force. So let's imagine that this box has a mass of, I don't know, 30 kilograms. Okay. So one thing that we know about gravity is that the acceleration from gravity is negative 9.8 meters per second squared. Again, so we'll mention this many times, but that's a constant that you'll see for the acceleration of gravity on Earth. And so now we can figure out what is the force of gravity acting on this object. And so what we don't know is the force of gravity. But a quick little calculation would give you the force of gravity. So we can set this up as the force of gravity is equal to 30 kilograms times negative 9.8 meters per second squared. So we have the mass and we have our acceleration. And that is going to be all we really need for force. So now we can just put that into our calculator here, where we have 30 times negative 9.8, and we get negative 294. So our force from gravity is equal to negative 294 newtons. Okay. And so now all we really need to say for the normal force is that the normal force is opposite of gravity. All right. The normal force, when things are at rest, or things are moving at a constant velocity, maybe in the horizontal direction, but especially for objects at rest, like sitting on a table or sitting on the floor, the force of gravity and the normal force, those are equal and opposite. So all we have to say for the normal force, I keep on writing n, but it's really F with a little n. And so that little n, or that subscript n, is a way for us to say, like, this is the normal force. And the normal force is just equal and opposite. So this is 294. And that's it, you're done. So force of gravity and the normal force are going to be equal and opposite, especially when objects are just kind of sitting still here on some flat surface. All right, one more example that I want to talk about here is tension. So here we have another beautiful drawing. Here we have a mass hanging from a string, and then it's attached to some kind of ceiling. All right, and so here we have the force of gravity. It's pulling it down. But then we also have tension. So we might call that F with a T for the force of tension in this string, and the string's holding it up. So as you might imagine, these are equal and opposite. So once we know the force of gravity, we can find the force of tension. So let's say this is a 40 kilogram box. So 40 kilograms. Once again, we know that the acceleration from gravity is negative 9.8 meters per second squared. Again, that's a constant. And so now we can figure out what is the force of gravity. What is the force of gravity on this object? And so we'll just put that into our calculator. We do 40 times negative 9.8, and we get negative 392. So this is negative 392 newtons. And so the force of tension, which is equal and opposite, should be 392 newtons. And again, what they'll point out here is that this is a positive number because that force is directed up, but the force of gravity is negative because it is directed down. And that's it. So I hope that was useful. I hope that gives you a little bit more understanding of how the normal force works and how the force of tension works.